All right, welcome back, everybody. So for those of you playing along at home, shout out Caleb and Jake. All we're going to do today is just going to review some problems. The first one I'd like to talk through is problem number 70. Was it 73? 73. I actually didn't finish this one on the key because I knew I was going to go over it with you guys, and I was like, man, you know what? I don't want to do this twice.
Why would you make us do it?
Because I'm a mean, evil person. I'm a mean old man.
Bro, that's taking over.
Did you just call me bro? Bro. I don't know. But I think you were talking. 73. All right, find a cubic function that has a local maximum value at 3 and a local maximum value of 3 at -2 and a local minimum value of 0 at x equals 1. Okay. How do we do this problem again? Because here's what I know. Oh yeah. Based on that information, I can get 4 coordinates. Based on that information, I can get 4 coordinates. 4 equations, basically. Let me show you how. You know, because I really want to find A, B, C, and D, right? I have 4 unknowns. How do you find 4 unknowns? You need 4 equations to do so, right? You got to think of this like a system of equations. I've got 4 unknowns. I need 4 equations to find those 4 unknowns. The first equation that I could have is I know that there is a point does exist on this cubic function at -2, 3, right? At -2, 3, that's the y value is 3, the x value is -2. So I can say a times -2 to the third plus b times -2 squared plus c times -2 plus d is equal to 3. We did this in algebra 2, but we did it with a quadratic. This is a cubic. And then we also know that a point exists at a local minimum value of 0 at 1. So 1, 0. So I know that it's a times 1 to the third plus b times 1 squared plus c times 1 plus d is equal to 0. Now, where do the others come from? Where does the rest of this come from? Well, I know that if it's a local maximum value of 3 at x equals -2, isn't -2 a critical point? And if -2 is a critical point, that means that f prime of x is equal to 0 at that value, right? So think about f prime of x. Let me move this down. So I know that f prime of x, which is 3ax squared plus 2bx plus 1c, just 1c, just c, okay. Right, all I did was just take the derivative, right? 3ax squared plus 2bx plus c. I know that at -2, I can take this point here. At -2, this is going to equal 0, right? I can basically say like -2, 0 is a solution on that. I can plug in -2 and it will give me 0. So that means that I have a a 3a times -2 squared plus 2b times -2 plus c is equal to 0. And I also know a minimum value is occurring at 1. So I know that 1 is another critical point. So 3a times 1 squared plus 2b times 1 plus c is equal to 0. Okay, now this is where it starts to get fun. Does everybody at least follow along to there? Okay, because I know the derivatives, the critical points are where the local maximums and minimums occur, and that's when the solution to the derivative is going to be 0, right? So that's why I took the derivative of f prime of x and ran through -2 comma 0. Now, what do we do at that from that point on? Well, I've got 4 unknowns. Now, do you notice how d is not included in my -2 comma 0 and 1 comma 0? I could write this plus 0d on here and here. And what I have created now is a system of 4 equations with 4 unknowns. I've got 4 equations, 2 red, 2 blue, with 4 unknowns. What does that mean? Well, take a look here. I'm going to write it in green to kind of summarize everything. -2 squared is positive 4. So 4 times 3 is 12a. And then I've got minus 4b plus 1c plus 0d is equal to 0. I've got 3a plus 2b plus 1c plus 0d is 0. Okay, now this is where it starts to get a little tricky with the to the third powers. -8a plus 4b minus 2c plus 1d is equal to 3. And then my last one here, 1a plus 1b plus 1c plus 1d is equal to 0. And now all we have to do now is just solve that system of equations. Now, when I looked this up on Slater, it said, okay, now use reduced row echelon form to solve this. And I'm like,
Let me just pull that.
right. Let me just pull that out of my brain. But we are going to use matrices, but it's a lot easier than that. Okay, let's plug it into our calculator. Right? Because this is the matrix equation that I have. 12, 3, -8, 1, -4, 2, 4, 1, 1, 1, -2, 1, 0, 0, 1, 1. And that's going to be A, B, C, D is equal to 0. Oh, I wrote the zeros like that. 0, 0, 3, 0. So we're going to plug this in. A times x is equal to b, so x is equal to, it's going to be a inverse times b when I get this all plugged in. So I go into my calculator and let's put this in. Matrix A, it's going to be, look, I was doing this with my Algebra 2 students. We were stuck to a 3x3 and a 3x1. It's going to be a 4x4 at 12, -4, 1, 0, 3, 2, 1, 0, -8, 4, -2, 1, 1, 1, 1, 1. And then I go back into matrix and I'm going to edit matrix B. And this is now a 4x1 of 0, 0, 3, 0. Okay. So I put it in matrix A and B. And now to solve this, I just take A inverse B. Go back into my home screen and write matrix A inverse times matrix B. And I believe it comes out to be fractions, stupidly enough. So let's put that back into fractions. I wish it came out to be whole numbers, but it doesn't. So that's my A, B, C, and D values. Okay, those are my A, B, C, and D values. So this means that that's f of x is equal to, I wish they came out to be whole numbers, 2/9 x to the third plus 1/3 x squared minus 4/3 x plus 7/9. You just take the x to the -1 button. So matrix A, and then you type in inverse.
Will you summarize this?
No. I just thought it was, who is calling me? Potential spam. Hello?
This is an urgent message for the vehicle owner.
It's an urgent.
We've been trying to reach you about your car's.
Oh my gosh, I have to take this. I have to take this. I am so sorry. It's about my car warranty. I've got to take. I wish it was a real person. I'd love to talk to that person. All right, any questions on that? No? Okay. What other questions do we have on the section 4.3 assignment?
38.
38? Let's talk through 38 then.
Oh, that's the one that was the inverse, just the derivative that you're supposed to do. I can't remember.
Right, and that was given for,
I know it's
36 times 4,
Yeah,
I
I
very
would
much
have
by
to
average.
This feels like the same. When they're weak in first review, because they're weak. Yeah, I just watched that, but also the opposite. I'm.
38? That's the one we wanted, right?
Yeah.
So find the intervals of increase and decrease. Find the local max and min values. Find the intervals of concavity and inflection points. Use the information from parts A to C to graph. Check your work with the graphing device if you have one. I will tell you this right now on the quiz on Friday. Well, can we talk about the quiz real quick before I do this problem? 7 questions on the quiz. 7 questions on the quiz. This is, there's only one of these. Okay? Now, this is like the whole back page of it. But because you guys just got to do a lot of stuff. And I will ask you to sketch the graph of it. Okay? Sorry. You will have your calculator confirmed, but I will want to see exactly where it is on, like I'll make you sketch it by hand. Like I'm not going to give you a pre-made graph. Yeah, and I want to see certain points. And I say that in the context of the problem. But there's only 7 questions. And a lot of the review problems that I told you might be a good idea to look at, those are just homework problems, which a lot of them you've already done, okay? I was asked if I could make up a key for the ones that have not been done on a homework problem, and I can do that. I can just write up some answers for those. But a lot of them are, especially the ones from the section 4.3 are ones that you've already done, okay? Trying to think if there's anything else I need to tell you about that. No, I don't think so. Okay, so find the intervals of increase and decrease, find the local max and min, find the intervals of concavity and inflection points, use that information to sketch. I have no idea why, but it just looks weird that it's not in standard form, so I'm going to put it into standard form real quick. So f of x is equal to negative 2x to the third plus 3x squared plus 36x. To find the intervals of increase and decrease, I need to find the critical points. So I take f prime of x is equal to negative 6x squared plus 6x plus 36. I factor out the 6 because I want to find when this equals 0. Let's factor out a negative 6. Why not? Negative 6 comes out. We get x squared minus x minus 6 equaling 0. I could just get rid of the 6 right away because I could divide it over to the other side. And let's factor this down. Factors of negative 6 that add to get to negative 1 are negative 3 and positive 2. So I set those equal to 0, so I have my critical points as 3 and negative 2. Yes? Say that one more time.
Why is it 0 when the negative 6 is pulled out? Because it's not half. It's just a
This? Set that equal to x? No, because the GCF doesn't include an x, so you don't have to worry about it being one of the zeros or one of the critical points. If it was like, if I pulled the GCF out, it was like negative 6x, then yes, you're right, I would have to include that as a 0. But since it's just a GCF of a number, I don't have to worry about that. Okay, so my critical points are 3 and negative 2. What else should you check? to find another critical point. Where it's undefined. Do I have to worry about that? No, because it's a polynomial. Okay, so I don't have to worry about when it's undefined, so my critical values are just 3 and -2. Okay, so -2 and +3, and now let's figure out where it's increasing or decreasing. So let's plug some values in and see what's going on. Can't cheat because I don't, well, I guess I won't cheat. I'll just plug it in. Let's plug in -4. We got -2 times -4. Oh, sorry. I'm going into the wrong one. Go back into F prime, right? Then go back into just F. -6 times -4 squared plus 6 times -4 plus 36. I don't really care the fact that it's 84. I care about the fact that it's negative. It's in red. I know that it's negative. If we plug in 0, it's positive, because these would both go to 0, so this is positive. I'm guessing that beyond 3 is negative, but let's just double check. Let's be sure. -6 times 4 squared. That's love. 4 squared plus 6. Well, that would be weird. Plus 6 times 4 plus 36. Negative. So it's confirmed the fact that it is negative. Usually polynomials follow a pattern like that. All right, so now that means that for part A, I can say, that it's decreasing on the intervals -∞ to -2 and from 3 to infinity. And it's increasing on the interval from -2 to 3. I don't know why I wrote a bracket there. That's a parenthesis. Good there? Okay, now, I have the option now of taking a look at the second derivative test or using the ID test to figure out whether it's going to be a maximum or minimum point at those locations. Because I already have the number line written there, it's pretty easy to figure out using the ID test. Because here, negative to positive, it's decreasing, then it's increasing, right? The function is decreasing, 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 then increasing. So at -2, is there a bottoming out point? Yes. So it's a minimum value. So we could say minimum at -2. Minimum at -2 comma, and we'll write the whole coordinate. And then I also know that at 3, okay, it's increasing, it's increasing, it's increasing, and then it starts to decrease at 3, which means that's a local maximum. Please excuse me for not writing the word local. How dare me. Okay, so let's, I know, you didn't write the word local. Let's plug these in to find the coordinates. Now, remember that I'm plugging them back into F to find the actual coordinates where they exist. So I would say -2 times -2 to the third power plus 3 times -2 squared plus 36 times -2, which it looks like -44. Just going to double check that. -2 to the third plus 3 times -2 squared plus 36 times -2. So -2 comma -44. And then the maximum is going to be at 3. So let's say -2 times 3 to the third. Come on now. -2 times 3 to the third plus 3 times 3 squared, which is at 9, plus 36 times 3. 81. 3 comma 81. Because I'm going to need those coordinates when I go to sketch. So it's important that I know the full coordinate. All right, now, part C says, find the intervals of concavity. Now, I could have used the second derivative test to figure out whether they were going to be local maximums or minimums, if I had not needed to have already done this interval test. But to do that, I would need to actually calculate out the second derivative. See, I don't need to do that until right now to find the concavity points, or to find the inflection points, if I had not already done this whole process beforehand. So f double prime of x is equal to -12x plus 6. Right? what do I mean by doing the second derivative test? Well, remember the second derivative test says if you plug in those critical points into an f double prime, that will tell you whether it's a local maximum or minimum. Like for example here, if I plug in -2, that's going to give me -12 times -2 plus 6. That's going to give me a positive number at -2. And since it's a positive number, that's a local maximum. Or sorry, local minimum. Local minimum, sorry. I always screw that up. That's one thing that like I need to like ingrain that in my brain. If it's positive, it's a minimum. I don't know why, but I visualize it like this. If it's positive, that means all the points in the function are above it. Okay. If it's negative, that means all the points in the function are below it. Like if I say 3, if I plug in 3, -12 times 3 plus 6 is a negative number. If it's a negative number, it's going to be a local maximum. Okay. It's almost like the opposite of what I would intuitively think it would be. All right, so -12x plus 6. The zeros of this, the -12x plus 6 equals 0. The critical points of that's going to be the possibilities of the inflection points. Again, possibilities of the inflection points. We subtract over the 6, and then we divide. So that's 1/2.
Yep.
1/2. So the possible, is that what you got? You're just joking.
No, look at it right here.
Okay.
Equals 1/2.
Okay. You're laughing while you say that. That's why.
Yeah.
I just didn't expect you.
You right?
Yeah.
Yeah.
I mean, it is on the second derivative.
Right. There's only one critical point, so I just got a test on either side of 1/2. So let's take a look here. If I plug in something at 0, that's going to give me a positive 6. If I plug in something at positive 1, that's going to give me a negative number. All right, so that means for part C, we know it's concave up from -infinity to 1/2. And then it's, nope, not anymore. It's going to be concave down from 1/2 to infinity. So that means it's an inflection point at 1/2. Yeah. Thanks. That's okay.
On the maximum and minimum, are you plugging that number into the original function?
Yeah, because I just wanted to know where is that location. You know, I'm not looking at what the sign is anymore. I'm saying, okay, when I go to graph, I'm going to need to know where that is. So if it's at -2, x equals -2, just going to go plug that back into the original to see where it ends up. So we've got 1/2 comma, and now let's plug that in. See, same thing here. I know there's an inflection point at 1/2. I'm going to see where that inflection point actually exists. So I'm going to go back into my original and say, okay, -2 times.
Hey.
Be out here.
You scared me.
Sorry.
Bye.
Is that true?
No.
Oh.
I had him last year though.
Oh, got it. That's just your teacher from last year?
Yeah.
Oh, that's nice. It's nice if you have that good of a relationship.
Yeah, we play.
Plus 3 times 0.5 squared plus 36 times 0.5 weekly. Okay, let me make sure I plug that in right before I got so rudely interrupted. Okay. 18.5. So 1/2 comma 18.5. Wow. Fraction then a decimal.
It's gonna be that weird.
Oh, that's not weird.
Oh yeah, -44 when you have to.
That's not weird.
44.
When you have to freehand a graph.
Oh, you just scale up the y value. Here, watch here. So inflection's at 1/2 comma 18.5. So now let's sketch it. Okay. So here's what I would do if I was going to sketch it. I know that the x values, that the points where I'm going to need to graph the x values are -2, +3, and a 1/2, right? So when I go to make my x-axis, I'll do it perfect. When I go to make my x-axis, I'm going to space these out. 1, 2, 3, Make it even on the right and left side. I know these are the points, the maximum and minimum points, -2, 44, 3, 81. So if it's at 81, maybe I'll just make a couple marks and go by 25. Does that sound good? So 25, 50, 75, 100. Thanks. Sorry about that. I went into my arrow. Is it negative at all?
Yeah.
Yeah, -44, -25, -50. And let's make note of that on the graph. So 25 and 50. Okay, so now let's plot those points. -2, -44. -2, -44, somewhere around in there. We've got 3, 81. 3, 81, somewhere up here. Sure. We know there's an inflection at 1/2, 18.5. So 1/2, 18.5. Okay. We know that it's concave up, looking like a smiley face, from -infinity to 1/2. I know that it's increasing. It's decreasing. Oh, decreasing. Sorry, I was thinking concave down and decreasing. Sorry. It's decreasing from -infinity all the way down to -2. Right? So something looking like that. Decreasing, and then it's concave up all the way to 1/2. And then it starts to go concave down. It inflects at 1/2. Then it starts to go concave down. And then continues concave down throughout the rest. Right? So it's going to come back down. Sorry, it looks a little jaggedy right there. Yeah. That's what I'm looking for there. I'm looking for where are the maximum and minimum points. Show me where the inflection point is. Make sure that the concavity is right. Make sure it's decreasing and increasing in the right spot. You know, I can check this off by saying, okay, it's decreasing from -infinity to -2, going down till -2, and then it increases from -2 to +3, increasing, and then it starts to decrease again. It's concave up here to 1/2, and then it goes to concave down, and that means that it's an inflection point at 1/2. Make sense? You have to do one of those problems, just one of those. Because that really tests, like, can you find critical points, which was a big part of section 4.1. You know, can you find all of those things? You know, a lot of the section 4.1 stuff is kind of included within this problem. Do you know what a local maximum and local minimum is and whatnot? Okay, yes.
So on 16, it's x squared element of x. So are you not able to use any numbers from 0 below that?
Yes. That's where it's a little tricky, because the domain is only anything bigger than 0.
That's not kind of fast, but I was
Yeah.
like.
Remember any logarithm?
Errors.
Right, any logarithm, you can't plug in anything 0 or lower. So you really kind of have to use that as part of your domain. So anything that may have existed over on the left side doesn't. What's that? Yeah, your domain is limited. Yeah. Yeah.
So this might be the question she was asked. I don't know. So if you're finding increasing or decreasing, and one of the numbers you get is 0, what is that?
Oh, yeah.
Okay.
Ah.
You're like, is it positive or negative?
Right. So if you go to the ID test.
I just said it was on the line. I have no idea.
So say, like, what are you saying there? Are you saying, like, you found a critical point and it was at 0, and then you went to the second derivative test to try to see what was going on?
No, like I had the critical point, and I did the numbers to the left and the numbers to the right, and one of the numbers to the left I did was 0. And then things.
Well, that would
I
be
probably did it wrong.
that would be an issue, because if it was 0 when you plugged it back in, that means that was a critical point. Yeah. But there are times when you get like something that you're plugging in that doesn't end up being one of the maximum or minimum points.
Okay.
Like, for example, here, what I'm getting at is, because that could come up, and it did come up on the homework. say you were, say you found a critical point and it was x equals 0, right? Say you found a critical point and it was x equals 0, and then you tried to do the second derivative test, and you said, okay, what's f double prime of x? Because that would tell me, f double prime of 0, because that would tell me whether if it's positive or negative, whether it's a minimum or maximum point. You found a critical point at x equals 0, so you think, oh, it's got to be a maximum min. Well, what if this comes out to be either positive or negative? What if this comes out to be 0? It's not a hole. That means that it was one of those ones where it bent through. So that means it's probably an inflection point if that happens. Okay? It's probably an inflection if that happens. It could be, yeah, because that was in the homework.
That means the answer is.
What did you just say?
It could be. But yeah, you got to watch out for that. If there is a critical point, because what would happen, you could check yourself with the increasing decreasing test. Because if you got a 0 there, something that looks like this would be increasing, this would be increasing. So even though you found a critical point at that part, this kind of looks almost like a big happy. So if you found a critical point at that location, because it's increasing then increasing more, there is a horizontal tangent, but it's not necessarily a critical point. The critical point would be, it's a critical point, but it's not necessarily a maximum or minimum point. Okay? And that happens when you take the second derivative test and it comes out to be 0 and not positive or negative. Okay? If you looked at it on the number line test, the ID test, you'd see positive, positive. And that would be a red flag as well.
Oh, yeah, it was in 23.
Was it in 23?
No, the one that I said forward one.
Oh, yeah. Because that's probably the same.
Honestly, this was like an hour and a half to do this homework experience, and I don't know, it's kind of.
Yeah, here. Yeah, you're right.
It was a horizontal one?
Well, you could say that it might be an inflection point, which means it's a horizontal tangent. But this is what we're getting at here. Like in 23, you say that there's a critical point that exists at 6, because f prime of 6 is 0. So 6 was a 0 of the derivative. So it's a critical point. But when you go to try to do the second derivative test, you plug 6 into f double prime, it's not positive or negative, it's 0. Therefore, 6 is probably an inflection point. Now, you'd have to test that. You don't know what f double prime is. You'd have to see, okay, is 6 really a 0 of f double prime? I do want to say this. Let's kind of talk through. Where are we at? You want to go back to algebra 2?
Yeah. Like it was the same credit.
Oh, go back to that. When did you do that? There we go. I want to look at what's in the homeworks and what's not in the homeworks. Because I need to do that for myself as well. So let me do this. Page. I am going to highlight the ones that are not in the homeworks. Okay? Highlight. So in page 283, the set 4-1 set, 5 was in the homework, 6 was not in the homework, 31 was not in the homework, 47 was not in the homework. Okay. Section 4-2, 5 was in the homework, 6 was not in the homework, 12 was in the homework, 13 was not. Page 301, yeah. 9 was in the homework, 11 was in the homework, 13 was, 37 was not, and 38 was. Did we just do 30?
Yep.
Yeah.
Did we do 37?
We did 30.
Oh, we did 38. Okay, got it. But you can see that 37, if 37 is right next to 38, it's probably very similar to 38. So you can kind of get an idea of the types of problems that I'll be asking on the quiz.
This is Friday, right?
Yeah, the quiz is going to be Friday, not tomorrow. So tomorrow, I guess I will just answer, I am gonna post the keys to section 4.3, so get your assignment's done. Christian, there are others, I only have 16 submissions right now.
I'm proud.
Proud of you. It's not good. So tomorrow, I'm gonna give you some time to check the answer key for section 4.3. I'll answer any other questions on that. I'll even answer questions about 4.1 and 4.2 if you wanna go back to anything from there. Or I'll go over some problems, from this review as well. Deal?
He is used more than once. Yeah, but I thought it was only used once. That's